Hi you guys, I just put out a video about factoring out the GCF, and this is another reason why it's good to learn how to factor out a GCF. There's something we're going to use called factor by grouping, and we'll talk more about that in another video. But when you do factor by grouping, you'll do it in two parts, and the second part is pulling out a GCF. So let me show you what the setup might look like. Let me give you a couple examples to show you what's coming up. So for example, remember if you have something like 2x plus 2y and you want to factor out the GCF, well, the greatest common factor here is 2. So you'd pull the 2 out. And so it would look like 2 times x plus y. Now this would also be the same if I wrapped these two in parentheses. Wouldn't this be the same? It's still 2 times x and 2 times y, or even if I wrapped the x and y in parentheses, this is still the same problem. So I wanted to show you that because that's how we're going to look at the factor by grouping. Let's see an example to show you what I mean. So what if I have something like x plus 5 times x plus x plus 5 times 6. Do you see how this is pretty much the same? Here's the common factor. Just like above, the common factor was 2. Now the common factor is x plus 5. That's the common factor that I'm going to pull out. So when I pull that out in front, I'm going to write this as x plus 5. That's like the common factor from the problem before that was the 2. And now what I have left over are these parts, the x and the 6. So what's left over is x plus 6. Can you see how that follows the pattern above? That the 2 and the 2 here is the GCF, and that's what gets pulled out in the front. Here I have x plus 5 and x plus 5, and that's what gets pulled out in the front. And these are the leftover parts. The x plus y are what go in the parenthesis, and here the x plus 6 is what goes in the parenthesis here. Let's look at another one. What if I have c times a plus 2b plus 2x times a plus 2b? Can you see the common factor? The common factor here is, in this case, it's on the right side of each term. So that's the common factor, and that's what I'm going to pull out. And I can pull it out in the front, or I can pull it out in the back. So I could either, maybe I'll write it in the back this time. I'll say, oops, a plus 2b. Oh, can't quite see that. Here's the a plus 2b. That's what I have on the side. That's this common factor that I'm pulling out. And let's see what I have left. Inside the parenthesis, I have this and this. So I have c plus 2x. So that's my factorization after I pull out that common factor of a plus 2b. It looks a little strange, but we're going to be using this a bunch when we do different types of factoring. Let me show you one more. M times xy plus 4 minus n times xy plus 4. Do you see the common factor? Common factor here is xy plus 4 and xy plus 4. This time I'm going to pull that in the front. xy plus 4 is the common factor, and then this is the part I have left over, the m minus n. That's what I'm putting in the next parenthesis, m minus n. It looks kind of strange, and let me know if you have any questions. I'm going to make a worksheet to put below so you can practice some of these. And one more thing, if I want to check my work, like I was doing above with other greatest common factor problems, is I can take this greatest common factor and multiply it in and see if I get the same thing. So I'm going to take this greatest common factor, I'm going to multiply it to the m, and I get this, m times the greatest common factor. And then for the second term, I take that greatest common factor and I multiply it to the n, and I get this, n times the greatest common factor. So it does work. It is the same polynomial. So I hope that helped. I'm going to help put some links below. Thanks. Bye.